Hello guys, welcome back to another video. So in this video I'll be showing you how to design a Sqaure wave generator or an Astable Multivibrator using op-amp 741. So here I'm going to use this OrCAD software which is installed. So the setup file, everything is available in C drive in the folder program files, OrCAD demo, and there is another folder called PSpice. And if you go down, there is a icon or a application file called PD design. So you need to open that. So this is PSpice design manager. So once you get this screen, then you can see that the left topmost button over here which says run schematics. So you just click on that. Then immediately you will get the screen that is PSpice schematics. So here is we are going to design the circuit diagram. So in order to do the circuit diagram, we need to import part by part components. So for that I'm going to import all the components. Basically for an Astable Multivibrator, which is a free running oscillator which contains 3 resistors and 1 capacitor and 1 op-amp, and we need to give power supply plus VCC and minus VEE as well. So I'm going to draw the circuit diagram. So for that I'm going to import all the required components. So in order to import the components, you can see that here nearer to this ground earth option. So here you click on this is place components and you will get this box. So the part name you need to give, for example, I can type R. So R in a sense resistor, which is, say here variable resistor is there, just R in a sense resistor. So just click on place, then move the mouse cursor to the dashboard and click once. So I need 3 resistors, 2 and 3. And next I need capacitor, 1 capacitor. So I just press C. So the C in a sense capacitor, CVAR variable capacitor. So I need capacitor and just click on place. So just place it here and just press escape, so which will go away from the components placing mode. And now I need this one called your op-amp. So your op-amp is mu A741. So which is highlighted over here, mu A741, and just click on place and just click on this dashboard once, then press escape. It's go away from that placing mode. And now I required all the resistors and capacitors, and also I placed the op-amp. So now I need one more power supply unit for basing the op-amp, that is minus VCC and minus VEE and plus VCC. So for that I need a DC voltage, so I can give here VDC. So VDC here, just click on that, place, and 2 times I need to place it because one is act as plus VCC and other one act as minus VEE. So both are plus 15 and minus 15 voltage. And another one I required is ground. So I can type ground and just choose ground earth. Just place it 1, 2, 3 and 4. Just 3 to 4 grounds are required. And now its part is over. So we have placed all the components, close. Now I need to connect all these components as per the circuit diagram. So in order to do that, so I just going to rearrange the components. So first thing is the capacitor. I'm going to connect this capacitor to this one, that is your pin number 2. So I just aligned here, and in order to connect this capacitor to the pin number 2, that is the inverting terminal. So we, in order to connect, in the top side we have an option which look like a pencil that shows a draw wire. So click on that, just point this pointer towards the capacitor, click once and just drag your mouse and click the other end. That's it. And as soon as you complete the connection, you need to press escape button, so it will leave from this wire mode. Again come back to the placing mode, and this one for now I am going to place this here, place these two power supplies away, since I need to place all other components. Now I need to connect the resistor R1 and R2 vertically, so just press here, and in order to rotate this resistor I go to view option, draw option, the option is Control R. So you need to press Control and press R button, so it will be rotated once, and if you keep on pressing this Control plus R, then you can keep on rotating vertical, horizontal, like that. And I need to rotate this one also, again Control plus R. Okay, fine. And this resistor I am going to connect here. So this one R2, R1 place it here, and this R2 place it here, and I need to connect this R1 and R2 together. So again connect these two, fine, and take one ground which is here. R1 is connected to ground. Again this wire tool, click on the one side of the R1 and connect it to ground. So this connection is over there, and I need to place this this circuit power supply. So just zoom it once, and this power supply here is a positive and here is negative. So as per the circuit diagram, one is plus VCC and other one is minus VCC. So the plus VCC is given to the terminal 7, so I need to place it here, and just I need to rotate once, so Control R. Okay, that's perfect, and just align little bit and connect. Use the wire tool, just connect the positive terminal towards pin number 7. That's it. Again, and I need one ground for that, so ground is taken here, and again this power supply is grounded to the other side. So I have given this power supply, and now I need to give the other power supply, that is minus VCC. So here the plus is here, I need to invert this to minus, so Control plus R. Okay, fine. So as you can see that minus comes in the top side. So now I can able to connect this pin number 4 to this negative terminal, and also I need to give one ground connection for this power supply. So place it here, and again connect this positive to the ground. So I have properly connected plus VCC and minus VCC. And also you need to give the power supply value. So in order to give the value, it is 0 volt here and 0 volt. So basically it is 15 volt plus 15. So I can give here 15 volt. Okay, and here also 0 volt, I need to give it as 15 volt. Yeah, that's fine. And once the supply is given, I need to connect the further connections. So I'll connect one wire to the output terminal pin number 6, and I extend it till here. That's it. And press escape. So just connected one wire and pick up again wire tool. From R2 I connected to this one output. Okay, so that's what the circuit. And once that is done, take one connection from this R1 R2 junction and go and connect to the inverting terminal, sorry, non-inverting terminal, that is a plus sign. Okay, and now I need to connect the resistor, that is R3. So take a connection from R3 and connect it over here between the capacitor and the inverting terminal, that is negative terminal. Okay, and also I need to connect the ground to the capacitor. So again take wire connection, the other end of the capacitor is connected to this ground. That's fine. Then this resistor which is connected to the output of the op-amp. So the connection is successfully completed. Now I need to give the values for each and every components. So first I need to give the capacitor value. So just to provide the capacitor value, here it is 1 nanofarad. So I need to change it. Just double click on the value, and so here as per the design the value is 0.1 microfarad. Just give u, which in the sense microfarad. So 0.1 microfarad, and the resistor R1 and R2, which is basically 10 kilo ohm. So here it is 1, so I need to change it to 10 kilo ohm, and R2 as well, it's 10 kilo ohm. And we have one more resistor, that is the R3 between the output and the capacitor. So that I need to change the value to 4.7 kilo ohm. So 4.7 as per the design. So this is the entire circuit connections. So basically one capacitor and 3 resistors, and we need to give 15 volt biasing to the op-amp. That's it. So the circuit diagram is completed, and now what we have to do is select one probe, that is voltage level marker, that is which is shown here in the top side. Click on that, then just place it over the output terminal, that is the output. Click there. Okay, that's fine. And if you require so input, then the capacitor voltage, charging and discharging cycle, that you can place it here. So that we will do later. So I just place the output voltage probe, the output terminal. That's it, output of the op-amp. Okay, fine. So now go to analysis tab, then select setup file, and in the setup file you are getting this window. So here you need to select the option transient. Okay, so click on transient. So as per the linear integrated textbook written by Ramakant Gaikwad, so the values that given in the textbook is that the transient parameters, that is the print step value, so which is 5 microseconds. So I need to change this value to 5 microseconds, and the final time, that I need to give it as 2 milliseconds. That's it. So once you give these two values, click OK, then close this. And now again go to analysis tab. Now you need to choose this time the second option, create netlist. So that's done. It is asking you to save this file, so I'm going to save it as Astable multivibrator. Astable multivibrator. Just save it. Okay, so if you have made any connection error in this particular circuit diagram during the time of this analysis and create net list, that time it will throw you some errors. So this time there is no error in my circuit diagrams and connections. So next, after completing this, again go to analysis tab and just click on simulate, and it will simulate the circuit. And once the simulation is completed, a window is pop up here. Just click on that. Now you can see that you are getting a square wave output, which is output of this op-amp, that is this square wave generator or this Astable multivibrator. And if you wanted to see the capacitor voltage, the charging discharging cycle, you can come back to the schematics and again select one voltage probe, and which that you need to connect across this capacitor junction. That's it. And again go back to the output window. Then you can see that this red color, that is the capacitor output voltage that is charging and discharging, and accordingly this waveform generation is there, that is a square wave output is generated. So the given supply is between 15 volt VCC plus VCC and minus V minus 15 volt. So this is your output graph, so that you can export using file, and you can print it, and or you can take a screenshot of that and you can paste it in your manuals. That's it. And hope this video helpful you to analyze the square wave generators and or a stable molecule. So the upcoming videos related to other simulations in linear integrated circuits are coming up, so stay tuned. Thank you for watching.